Hi everyone, welcome to the first Brisbane AI user group. I'm JK, co-organizer of the event, together with David and Saraf. For this talk, Valeriia and team will make an introduction into cognitive services, show us how to use speech recognition, and demonstrate an open source project for managing transcripts and custom speech recognition based on the fixes we've done in the transcripts. Let's get started.
So can you, someone has to tell me if you guys can see my screen.
Yeah, we can see your screen.
Awesome. All right. Well, I'll not try you to kind of do just the slides, but I thought it would be nice to level set. I'm not aware of what backgrounds you guys have on the call, and I'm still getting used to Zoom. So it's like a thing popping from the top. Awesome. All right. Cool. So I thought it was useful to kind of give a little bit of an overview over the cognitive services, and that we can dive into the solution as to like even why we called it, building the face-off for Azure Speech Cognitive Services. Sounds really cool. I really like the title. But if you're not familiar with Azure Cognitive Services, we have a collection of APIs that enables customers to democratize AI. Someone wants to enter. Do I just admit? Someone has entered the waiting room. Do I admit?
Please.
Yes,
please.
because I'm now the host. Cool.
Valeriia, can you make Saraf as a host so he can just accept everyone for you? You'll still keep sharing.
Oh, yeah, really? Okay. How do I do this?
Yeah, just right-click on his name.
Participants, cool. And then more.
Yeah, sorry about that. We didn't have more licenses for Zoom for more than one host.
Don't say
That's
that.
Okay.
Keep it away.
Awesome. So is that all fine?
Oh, good.
Yeah, that's fine.
Cool.
I'm sure we're able to manage that now.
Awesome. So so as part of the Microsoft stack, we have a collection of cognitive services that help you in some way to democratize AI. So in this case, if you don't want to get hands down with Python and data science and all that other magic, you're able to build applications using some of the cognitive services that we have. So we have a collection for vision, speech, language, knowledge, search, and labs. And this is kind of the grouping under which Microsoft has put together a few of the services. And the idea is you come into the portal, or there is other means of creating a service. You create, for example, a vision service. It gives you a net point that you can then call and pass your data. For example, for vision, you can pass it an image and get some data back. So why using cognitive services? As I mentioned, they're just simple REST calls. And you can very easily start implementing with it because there's just one place you go to. So if you want to check out all the cognitive services, it's just www.microsoft.com/cognitive. And you're able to see the variety of different services that we have. It is flexible, so that means that depending on your independent of your background and the language or the frameworks, that could be iOS, Android, Windows, could be Python, and so on and so forth, you're able to use the services and create the applications. And then test it. We've had a lot of big customers and enterprises, and smaller customers as well, build really cool solutions using the services. And you can find on customer stories. This is something that I usually get to look through and to get inspired as to what other regions are building with those services. So on customer stories, you can see how some really big customers implementing that as part of their environment. So when we go and have a look into kind of each of the categories, you can see there is a lot happening, and it gets sometimes overwhelming. So this is why I like to kind of look at some of the sort of use cases to see where would I apply it with what. And given that I'm in that ecosystem all the time, it is quite fascinating to see how many various services that we have. And this is not all of them. I think this is not so much. It's not so much an outdated deck, but maybe it's 6 to 12 months when it was released, and so many more services were added, like form recognizer. I don't think so it's on it. So we will look in just a bit. So some of the use cases and services that we have, for example, under vision, computer vision. So we're able to get information from images. We have things like content moderator. So you can think of, moderating potential offensive images, text, or videos. Things like face API. So you're able to identify faces and emotion in the images, and what's called the video indexer, which is something that I am getting my hands on at the moment. So you're able to extract insights from a stream of videos. And under the video indexer is just one endpoint, but it can actually has speech to text under the hood, sentiment analysis, and all of the other cognitive services to kind of make it a, sometimes it feels like it's a full-on SaaS service, just because of how much functionality it offers. Then we move down to speech. And the things like JK has mentioned at the start, have things like speaker recognition. So you're able to identify and authenticate individual users. We have things like custom speech services. So this is trying to overcome the issues with different vocabulary or speaking styles and things like that, or background noise or vocabulary. So let's say we've had a really interesting customer scenario of a call center. And as you can imagine, there could be a lot of background noise happening. So you can train your service to understand and eliminate that to get really good results on the other end for transcription. We have things like under language, and I know bots have been around for quite some time, but it's something that I learned with bots. So things like language understanding intelligence service, which is LUIS, and it's really nice flows whenever you are building an intelligent agent. So it helps you sort of understand and extract intents from the text. You have text analytics. So you're able to, evaluate sentiment, language, extract key phrases. So an example could be you are using first your speech to text service to transcribe the recording. You get your text back, and then you can run text analytics to then extract key phrases or sentiment. So in the call center scenario, you can see it in the way you have an agent and a customer speaking to one another. You're transcribing it, and then maybe you can have like a smiley face set or happy on the side to kind of give an understanding of how good, or so sort of what's the quality of the call. And the last one, under knowledge, we have things like Q&A maker. So this is the ability to extract information from the unstructured text. So that could be your PDF documents, that could be your frequently asked questions. And once again, I think this is really nicely flows into the chatbot. If, say, you're building an intelligent agent, you can combine your LUIS with the Q&A maker to give like really good user experience. So your bot doesn't always say, sorry, I don't understand, sorry, I don't understand. And search as well. All right, so some of the use cases. So for computer vision, as you can see, you're able to extract information from images to help you, let's say, categorize or process the data. Under speech, you're able to convert your audio to text. Maybe you then want to run your LUIS to understand the intent. And there is also a service which is still in preview that helps you to do text to speech as part of the same, so you can train your model to speak as well. Under knowledge, it's of course your Q&A maker. As you can see here, they're giving an example of a chatbot, and then search as well. So you're able to use Bing search to bring you information. So this is an example of the vision, and I think it really goes deep into every single service, which, as you can see, there is a lot. So if you're not familiar, and I'll try to now share it. Can anyone tell me if they see the computer vision website page at the moment?
Yeah, we can see it.
Awesome. So you can come in here if you are something happens in the chat. If you're not familiar with it, you can come in and play with it. So you don't even have to create a service, although we do have a number of free API calls that you can have for every single service. But if you don't want to even go into Azure and spin up the resource, and you just want to see what sort of information it can bring back to you, you can come to the computer vision, scroll a little bit down, it sort of tells you. And let's say you want to test an image, I'll just browse one. I'll put my face into it. Let's see what sort of age it thinks I am. So as you can see, and it's in the same way, you can pass that image to as an API call, and this is all the tags that it's giving you. So it's saying that it's a headshot, a name, person, what confidence it has, and all the other tags that I have: brown hair, layered hair. Oh, that's very specific, and so on and so forth. You can look at different descriptions. I'm trying to look at the age. It always brings you the age back. Maybe it's a little bit. Then, oh, there you go, age 28. Well, that's not bad. A few years off, but I can, I can take that. Gender female, and so on and so forth. So it kind of gives a little bit more information about the text. And obviously, this is not very rich photo. It's just face of me, but you can see sort of what information it can already give you just from that particular image. You can see other. There is one for celebrities. For example, I'm gonna try and do Satya. Yeah, so you can see 49 and so on and so forth. Then we have a few other ones. If we have a look at the custom vision. So with custom vision, it's built on top of your computer vision, and you're able to upload a set of images that are specific for your environment and tag them. So for example, if you are building a solution for a industry that has certain equipment that the baseline model was not trained on, you're able to add images and train that for it to be able to recognize. So for example, maybe it's a certain shape of bolt, or maybe you're developing a solution to scan packages. You can add all these specific images to the custom vision portal, train it and deploy. Then the next one, oops, not sure how to. Yeah.
I've got a question from Craig. He wants to know how old you are.
I am 24. So it was a little bit off. Well, turning 25 in a few days. So yes, I actually didn't do that bad. Then we have service which is called speech to text. And in here, once again, you can come in and test a few samples. And I probably need your guys' assistance. Will you be able to hear if I play it here?
Yeah, we can hear, but I think when you don't remember exactly. It's not
a big problem for now, but it's basically, yeah, you can come in here and you can see, you can listen to different audio samples. And let's say, and it will show you what was the baseline model, right? So unfortunately we can't hear it, but it has a lot of background noise. So it will say, show me all flights from Pittsburgh to Boston is directly connected at Martin Peach Burger after 7. So as you can see, it didn't really do that well, but once they trained the model using the custom speech service, it was able to get a much better result. So it's either used a few of the samples of the audio with the background noise, or potentially a phrase list that had Pittsburgh, Boston. So the model has an understanding of what sort of data it is expecting to see. So once again, yes.
I shared the URL, so if anyone wants to try it, they have the URL in the chat.
Yep, so you can maybe play it now for yourself and just see. So English only, classic US, please show only class Q at 6. So you can give it sort of examples of the phrase lists. Then the other one, which I am the most excited about to play with soon, is Form Recognizer. And I saw a lot of demand from customers in the past couple of months about it, and a lot of people are actually already using it. Be mindful that it's still in preview, which means that things can change, and the way you implement call to an API, they can change the format, the definition, and things like that. So just be mindful whenever you're developing something that is still in preview. that it can change. But the idea is you can give it a form, and it's able to index the form and give the parameter, a name, and then what it is. It's a foreign and etc. Let's say we can look at this one, which is a receipt, like this. And then did I do it already? Yeah. So it says merchant, address, phone number, and so on and so forth. In addition to that, which I don't really see it here, you can do custom forms, custom training for forms, where you're able to give your exact examples of forms and to train that model. So it can be a little bit more accurate for your specific data set.
Valeriia, I've got a question for you.
Yeah.
You're saying that the form recognizer is already being used, correct? So who's using it out in the market at the moment? So is it out in production, or is it just?
No. So that just a few of my customers were playing with it. I haven't really seen anything in production just because it's still in preview. Okay. So which means that things can change, the pricing model can change, the way you, for example, given that it's an API, the Swagger API definition can change. So yeah, a lot of customers have started playing with it.
You know when it's supposed to come out of preview into general availability?
No, unfortunately, I don't know at this point in time, but in the past couple of months, they've added a lot of functionality to it. So it has been in preview for now around a year or so. So hopefully soon they will give us a little bit more information. But from build, I was expecting something from build, but unfortunately nothing came out. So team is still adding more functionality to it.
Yeah, and if anyone is interested, I actually have made a talk about custom form recognizer because we're using this for our SSW events to do user feedback evaluation.
Awesome. Can you share it with in the chat so I can check this out later as well?
Yeah, sure.
Awesome. Thank you. So that's that. And yes, I think all the other ones, all of my slides are just showing sort of what you can do with various services. But I guess you can lock down maybe a particular use case, and the way I usually kind of get to learn all those technologies that I find a project that I want to build, I'll explore. So let's say I want to recognize the form, so I kind of take that service and try to build a solution. So yeah, there's a lot of things available. That kind of gives a little bit of an overview of some of the cognitive services, just because it's way too many, and I'll probably be talking for 2 hours about all of them. So I'll try to kind of keep it a little bit more condensed so you guys have a little bit of an understanding. Before we go to sort of the next part into the solution that we put together, any questions, or have you guys, maybe anyone built something cool with the services that they would like to share?
No, I mean, similar sort of thing. I was using this to build a point in time, basically to analyze text and spit it out into speech, but I was using Python code mostly, but I was calling the endpoint speech to text endpoint to do that as well. But nothing production ready just yet. It's just more similar to you, from the form recognizer, just building something that can be made and sold to the clients or taken to a client. Just more demoing than anything else.
Yeah, nice, in Python as well. Very cool. So so kind of the next part is what we would like to talk about, and this is what more or less the user group is about, is the solution accelerator that myself and team have put together. And you can navigate to Team's repository, and then maybe we can put it in the chat later, or maybe team can throw it in. It's an accelerator that we have put together for customers or you guys or anyone who wants to get a little bit more of an understanding how to use the services. Just a disclaimer: it is not officially endorsed by Microsoft. It is not an end-to-end solution, and it's just a starting point for you to understand how to use the services, start playing around with them and just see whether even the service is useful for your particular data set. And then here I'm just putting a link saying, navigate to Azure Application Architecture Center to make sure that if you do deploy this solution, you put all of the measures around it to make it scalable, resilient, and highly available, and so on and so forth.
Sorry, but I shared the link so everyone
Awesome.
can pick it up.
Thank you. So what we found with working with a few customers is that although cognitive services is a really good way to start, and it's democratizing AI, and it allows customers to generate insights a lot faster than, let's say, building your own model from the scratch, it does still require a little bit more of a understanding of Azure ecosystem and Microsoft ecosystem. If you want to build something that can be tested, and as you can imagine with the speech to text, you'll probably need someone to look over the data and just seeing how well the transcription is happening, as well as most of the end users could be data scientists, might be researchers, might be business analysts that might not necessarily have a lot of developer background and skills. So this is something that we were driven by to create something that would enable customers to come in and where's the magic button, click Azure Deploy, and I'll pass over to Tim soon, so maybe he can explain how he implemented that. And it's using Azure Resource Manager to stand up the whole solution. So it abstracts a lot of bits and pieces under the hood that you're able to create the solution and use it and test the functionality of it. I'll really briefly talk through an architecture, and then I think it will be a lot more useful for Tim to demonstrate how it works. But the idea is we have two parts to the solution. One part is here at the top, and you can read through what sort of 1, 2, 3, 4, 5, what are the steps. We tried to make it as simple as possible, but the idea is there's two parts. One is called the transcription viewer, and I should have changed that, but spelling. One is called the transcription viewer. It enables customers to deploy, to upload audio recordings, get it transcribed using Azure text-to-speech cognitive service, and give back the transcript and visualize it in the way that customers can actually consume it. Because as you can see, usually it just gives you JSON file, and then you have to parse it, and then you have to show it somehow. And then what if you want to listen to the audio as you're looking at the transcript? This is kind of step number one. And then step number two is the custom speech training. So if you played around with custom speech for Azure Speech Cognitive Service, there's a lot of that comes into the data prep. And then maybe I can even show real quick the data file that it is expecting. So you need to give it a file, and this is just an example of one, of your audio being cut into 1 minute segments, right? So you have to take an audio, cut it into 1 minute segments, and it's good if you're familiar with how to use all the various audio packages. If you're not, it will require Google search and a little bit of an understanding, as well as you need to provide a text file with an audio file name and the text. So every time we would sort of mention that that's kind of the data prep that is required to train your model, a lot of customers are quite overwhelmed, and we understand it, because in this case, it was a 3-minute video. What if you want to train for, let's say, 2 to 3 hours? So our idea was to use, once again, sort of that event-driven architecture method using functions, triggers to automate the cutting and data prep. And I'll just scroll a little bit down, and I'll do it after maybe Tim shares. We use this FFmpeg library to do the cutting. It's not a preference or anything, that's just the one that I was familiar with. There's a lot of other ones that you can use to do the same, to sort of do that cutting and prep of the audio, but we just chose with the FFmpeg just because I was familiar with it. When you create it, there is a cost associated with it. We try to make it as free as possible. I think Tim has the functionality to even scale it down to the free tier after it deploys for the app service to host the web application. But apart from that, you will only be charged for the amount of calls you will be making. So that is how much data, how many audio calls you're transcribing, and how much data you have in your storage accounts. If you're familiar sort of with how Azure pricing works, I kind of put a few links here, but please go and check out a little bit more accurate on the web. And
Larry, a quick question. So the use case for this would be within a call center, correct? To do.
Yes, that's correct.
Okay. Would you use it anywhere else apart from a call center as a use case?
Well, well, that could be, for example, if you're analyzing recordings, let's say if you're a researcher, I need to analyze various interviews, that could be a way you can approach it. We've built it in the way to show how you can use all the bits and pieces as part of the cognitive services to make something like this, as well as enable customers to just test whether kind of the performance of the cognitive services. Because if you want to see, how good your data is and how well it transcribes, you need to upload a lot of data. Then you need to listen to the audio and look at the transcript. And it's just a lot of work that is required to even test whether it's something that you want to move with. So this is kind of just two use cases. You can use that for the call center scenario. Maybe you want to use that to just test the performance of the services, or if you just want to learn how everything sort of ties in together with Azure. I think it's a really good learning exercise as well.
How long would it take someone to actually build something like this? So provided they don't know anything about the services, they're learning from scratch, sort of thing, or at least they have a high level overview. How long would it take? Would you say it would take to build this?
That's a really good question, and it's it's really hard to give. Probably some time, and obviously you guys have there's docs, and if you're working through that solution, we are here as a team to help as part of the FastTrack team. Usually how I recommend is to starting with something like this available, or any reference architectures that are available on the Azure Architecture Center, to see what's available there, and then take it step by step. With us, personally, it took some time to put it together, just because our solution was sort of guided by our customers, what they wanted from us. But yeah, team, what do you think? What are your thoughts on, let's say, on someone who doesn't have Azure skills to build something like this? How long would it take?
Yeah,
based on your experience?
It's probably a little bit unique because I use this as an opportunity to teach myself Angular. So there was a lot of pain while I ramped up on that, which soaked up a bit of time. So I couldn't use this as a great example. But the initial version that we did, we had a working solution in about 10 days, from me knowing nothing about cognitive services to spitting out transcriptions that we could use.
Cool. Sounds good.
You can also see there is that sort of first solution that team has mentioned. I think it's under the master branch. Yeah, that's kind of our V1. And maybe from here I can pass over to team to sort of speak through the solution.
Awesome. So is that coming through now?
Yeah, I think we can see your screen.
Awesome. So I guess I'll give a brief background on kind of how we put the demo together, and then I'll jump in and do a demo of the demo. So as Val mentioned, we kind of started with the master branch here, and this was driven mostly, we had some customers that really wanted to play around with speech to text, but didn't really understand, as Val mentioned, the Azure ecosystem. So we created a very simple solution. You uploaded your audio to our blob storage service. We had a trigger that fired off a piece of code, in this case an Azure function, which queued that particular file against the cognitive service. And then when it was finished, that would we had a polling trigger, which just every 15 minutes checked the service for the status, and then would copy the transcription back. And so very, very basic solution. Customers liked that because they could easily just drop some files into a storage account, and then they would have some transcriptions pushed out sometime later. If you ever have a look at the demo code on the Cognitive Services website, It involved like downloading a sample from GitHub, using Visual Studio to modify the sample, and then debugging that. So the aim of this was that customers just come in here, hit the deploy to Azure button, which is up the top here, and then drop some files in and play with the output using their audio. As Val mentioned, there is that speech to text Azure page where you can sort of play with sample audio. But if you wanted to play with like, maybe an hour recording from your call center and things like that, this is where this really sort of was born. And then when we were showing this to a few customers, it became pretty evident really quickly that even just giving them JSON output wasn't really enough. So when we were talking to the actual researchers or the people that wanted to consume the transcripts, just giving them blobs of JSON still wasn't enough. So that's where the next iteration of our solution really was inspired from. And so we came up with this idea of a transcription viewer. And so the idea here is that we have a web-based interface that allows you to easily upload the audio to the storage account, but also allows you to review the transcript against the audio. So a lot of the feedback that we're getting is that most people want to understand how good the baseline model is. So before I invest any time in learning cognitive services or building a solution on it, I need to know whether your service can provide enough accuracy for me to do the things that I need to do. So given my environment, my level of noise, my vocabulary, am I going to get what I need from that solution? So that's really what this was about. So once you hit the deploy to Azure button in this particular markdown, you should get a transcription viewer application at the end of it, which is an Angular app. And I would just call out now, as I said, I learned Angular. I use this as an opportunity to teach myself Angular over the Christmas holiday. So please don't use this as a reference project by any means. There's definitely a lot that could be done better. I've learned a lot in the progress. So, but this is it. So basically we've got a create transcription button here, so I can easily go and choose a file from my storage account, or I can upload to my storage account. This is a test. Let's go with that. And then, if I want to, there's a whole bunch of knobs and dials that I can play with on this particular transcription. So we want to do speaker identification? Do we want to have different punctuation settings? Do we want to remove profanities and things like that? So I can go ahead and I'll just leave it with the simple. So basically selecting a file, setting a title, and hitting submit. That's going to go ahead and queue that transcription against the service for me. And then once you've done that, you can go ahead and open a transcription. And this is kind of where things start to get a bit more interesting. So what we've got here is that when you transcribe using a speech service, you'll get a JSON document that lists basically the offset, the utterance that was uttered. And what we've done is we've tied together those things with the audio file. So if I turn on auto scroll, for example, and I know you guys won't be able to hear this, but as I play this audio file, let me just, so I don't have that really loud in my ear. As it's playing, it's highlighting the utterance that's currently playing. And that does a few things for customers. It really helps them, identify whether the model's accurate enough for them. And then the other thing that we can do here is, if we're just reading through the transcription and maybe we've noticed that, oh, that doesn't quite look right. So I don't think that we would have said your points are not working, for example. So it got it wrong. So I can actually click on that utterance and that's taken me directly to that point in the audio so I can listen to the utterance and see what it was. So this was all really aimed at helping customers quickly identify whether the baseline model, which we've used to transcribe here, really is going to provide enough accuracy in their environment for them to do what they need to do. And then once we started working with this idea, we quickly realized that we could actually just allow customers to edit this particular one. So in this case, just listening to the audio, then I heard it was not points, it was phones. And the idea here is that this then becomes a feed for our custom speech model training. So one of the prerequisites for custom speech model training is that you have 100% accurate transcript. Some customers already have that from previous transcription services. Some of them don't, and they've got to build that out themselves. And so we thought this would be a great way. If we can get you 80 to 90% of the way there with the baseline model, and then you just come along and you're tweaking the model in a few spots, that gets you, a large portion of the way there in terms of evaluating custom speech, and whether if let's say the baseline model is not good enough for you and you want to build a custom model, this helps you build those practices so that you can then train potentially with hundreds or thousands of hours of content. So once you've got your 100% accurate transcript, you can go ahead here and hit the train button. And what's that at that point will do is it'll break out and call Val's functions. So in this case, it calls what we've called cutter function, which does the splitting of the audio into the 1-minute chunks, which Val mentioned earlier, and also splits the transcript into the appropriate text file. And then we pass that off to the custom speech portal, which you can see here. And then once it's successfully imported, it will kick off a custom model, which hasn't started yet. And
Kevin,
then
I've got a quick question for you.
Yeah, sure.
So Ankit in chats asked, how do we train back once the transcript has been modified?
Yeah, so I think I just covered that. So basically, at the moment in the Solution Accelerator, you can hit this train button, and it will basically take the updated transcript and send that to Val's function. And then that's what's going to do the feedback mechanism and retrain the model for you. And then once you've got a validation that the model was successfully trained using that data set, you'll actually see it appear down here in models. So by default, we're just showing the baseline models for that particular locale. So if I choose a different locale here, it'll reload the models. And if you've got custom models, they'll show here. So if you wanted to test your model versus the baseline model, you could come in and resubmit the transcription and then compare the two. But yeah, that's what this, in terms of what's actually happening when you hit submit for training, it's calling this function, chopping up the audio file and preparing the zip file that the custom speech service wants. So if we jump into the custom speech portal, and if you want to try this, you can do all this without using Val's functions. If you go to speech.microsoft.com, you hit sign in, you'll come into the custom speech portal and you can do a lot of this. But as Val mentioned, when customers saw the steps involved in, say, taking an hour-long call transcription, chopping up into 1-minute things, and then the few customers that we've worked with, when they look at their transcripts, it's literally a Word document. So you've then got to sort of sift through the Word document and look for the marker at that 1-minute mark, copy and paste it out into a text file. It's very tedious. And we worked with the initial customer that we worked with. We sat with them for about half an hour and got about 4 minutes of training out of it. So I'm sure once you did it a few times, you'd get a lot more efficient at it. But the idea of this was to try and automate some of that process. And so once you've got your, you can see here there's upload data. So we do all of this for you. We basically create the zip file. We upload it here as a thing called a data set. But you could do all this manually if you wanted to. So you would say, I want to upload from a local machine, and it's going to ask you for the zip. But we've done all of that for you by hitting that train button. And then at the end of it, you'll have a custom model defined here that you can then choose to do your next transcription against. So just a few caveats there I would call out. When we've spoken to the product group, they've said, this is a good way of experimenting with building your own custom model. They did issue a caution. So basically, because we're using the utterances, if we go back to my sample here, because we're using the utterances here to break up the audio, there is a potential if this particular utterance offset wasn't 100% accurate, and we chopped the model in the wrong spot, chopped the audio in the wrong spot, that could potentially cause a regression in your new model. And so their suggestion was the best way to do it would be to use the cutter function to generate the data and then have a human review it. Now, in the testing that we've done, it's been pretty good. So we haven't had too many issues with that. but if this is something that you're looking at doing, as part of a pipeline, you might want to look at other ways that you could split that as well.
Yeah, David wants to know about the data prep really. To start off with, so how did you go about prepping the data initially?
Yeah, so Val, did you want to jump into a bit more detail into, like, essentially what we're doing is using FFmpeg to split the audio, but Val, I'll let you cover off in more detail what we actually did there.
Awesome. Can you guys see my VS Code?
Yeah, we can see it.
Yes.
Awesome. So I don't really have any data science background. So it was just me taking what I know and trying to make it work. And more or less, as I mentioned in here, there's a few libraries that helps you work with audio files. So FFmpeg or Librosa, PySox, PyDab. So you can basically have a look at the one you want to work. I just had some previous experience with FFmpeg library. It enables you to use a few commands and do chopping at a particular point in the audio. So I don't necessarily have, actually, let me check in my Postman if I have the raw file. So, sorry, I'm just jumping between back and forth. So in this particular example, once the user edits the audio and tries to make it as accurate as possible, you then send a command to the kata function, which is just a webhook HTTP trigger. And as part of that, we're sending it the full transcript. Once you train your model, once you get the response from the Cognitive Service API, it gives you the JSON format with utterances, which are chunks of text, and the timestamp at exactly when that particular sentence has started and when it has ended. So we're using that as a reference to cut the audio file. So what I do here is that, obviously I don't want to get too much into the details, but team is sending me as part of the request that whole JSON document. I'm then going through it and looking at it and creating chunks, which means that I'm just going through all the utterances and adding up the seconds. So let's say I have 5 chunks, each of them, let's say 20 seconds. So I'm adding them up. If it goes above the 60 seconds, I go to the previous chunk and cut it. And that would be my 1-minute audio. So once I do that in here, we're using the FFmpeg library. And this is just me doing what it told me to do. More or less, it has the time start and the duration. So time start could be, you're starting at 0, and then the time stop could be that 59 seconds, and then you cut it. And all that I then do is that I save it to my text file that I have here, all the text, and I save it to the Azure Blob Storage as a zip file, and that's it. So if I can find, I'm just trying to find an example of the JSON file that it sort of returns. Give me 1 second. You can obviously do it without Azure Function. You can download the FFmpeg library or use Audacity, for example, and manipulate the audio and cut it into 1 second increment. We tried to use whatever the Cognitive Service was already giving us as a starting point, because it returns already all the text and exact time placement for every single word or utterance. So we just use that as a reference point and just chopping. Obviously here, as Tim has mentioned, there is the caveat that it might not be 100% accurate. So there might be a few times where you have the audio that is overflowing a minute or before. It might not be an exact representation of it. So this is where the product team has advised us to have a pair of eyes look over the data, just making sure it's 100% accurate. Unfortunately, I did not have the sort of raw JSON file as part of the request that team is sending me through. Yeah, I don't have it. So, yeah, but did that sort of make sense? I know I'm just trying to picture it in your mind how it all actually works, but hopefully that sort of makes a little bit more sense.
I think like we've probably demoed the bulk of it. So Jaco, we might throw back to you and sort of happy for you to take it from here.
All right, so yeah, really thank you for the presenters for this awesome talk. Like, yeah, this is quite amazing. I know that quite a few clients wanted to have something like that working, and I basically did a similar demo like this, but console application, and you just either work with microphone or just put a audio file, and then you just throws out the answers. But this is like really well made. If we can use that, I mean, a lot of people would be happy.
Yeah, that was the idea, is that we can get as much reuse as we can, because we had similar experiences with our customers. So
I have one question, Tim.
yeah,
Here. By the way, the UI is fantastic. It's maybe colors wise, it's maybe not good, but the function is really good. The audio file, as per the design, you are putting it to the blob and then retrieving after some time. If I have an audio of like a 5 or 10 second, I'm trying to make application where I'm trying to parse or send a voice message, and I want to act on a voice message on some deployment or something. So I want to analyze what the voice message is and want to do something.
yeah.
So the message, I want to do it straight away. So is there a issue that this functionality kind of takes long time and there's no way to do it straight away? It's like it's supposed to be always asynchronous.
Yeah, so that's a great question. And basically what we were demonstrating is what we call the batch API. So it's all about asynchronous, but there is a real-time API. So you can, there's an SDK available for that, and you can basically stream data straight to that, and it will respond with the text synchronously as well. So if you've ever used Teams and seen the captioning functionality in that, that's effectively the same thing. Yeah.
Okay, so API call will wait until it translate and send it as a part of the return callback. Is it?
Yep. Let me just find the reference for you. But that's the crux of it. So basically, there's two APIs. One's the batch, which is all about, hey, I've got this really long audio file that is going to take several minutes, and then there's a real-time API, which is, hey, can you, like for scenarios where like captioning and things like that, you need to get it back straight away.
Cool.
All right. Well, we'll still wait a little bit for questions, and I'll just take over just a little bit to show you a few things. So let's share screen. So if anyone is interested in doing any talks at this user group, I think we have one reserved, not this one, another talk. But what you can essentially do is just go to this URL, which Saraf is going to share. You can just go new issue, and you can put the title and the description of your talk. And then if we look at here as an example, we're going to tag it, what level, and all of that stuff. And then we'll try to schedule it for a user group. So you can, if anyone wants to present, this is a way to do it. You can also send us an email. And if you have an idea what you want to hear, you can also make an issue over here and say, hey, I want to hear more about TensorFlow, for instance. And then we might try to find a speaker that does TensorFlow. All right, so with that, I would again thank the presenters for doing the presentation. The presentation was really, really good. I would love to thank you participants for being here on the first user group. I just noticed I don't have video over here. That's better. So thank you for coming to the first user group, and hopefully you'll come back, spread the word around. And thank you to David and Saraf. They are the co-organizers. They helped a lot, even though I was the one that talked the most. David did so much work behind the scenes, it's not even funny. So thank you for coming, and I hope I will see you next time.